Hi everyone, my name is Benjamin Williams. I'm a research assistant at the School of Computer Science, University of Lincoln. And today I'm going to talk all about shaders in Unity. So this is one of my favorite topics to talk about. I absolutely love anything to do with shaders, anything to do with Unity. So yeah, in this talk, we're just going to have a very brief introduction to how to make shaders in Unity, what shaders are, and have a look at the kind of old way of making shaders as opposed to the kind of new ways of making shaders. So we're going to cover all of that, but I don't want you to think that at the end of this you'll be a shader god or a shader wizard or something like that. It's just intended to be a very brief introduction to shaders. Hopefully it should give you enough to go off in some direction and you should be able to do this stuff yourself, but I'm trying to get across how much I love shaders and how important they are for games development. If you have had experience in Unity before, then that's probably best. I mean, it's great if you've got experience in Unity, you'll understand what I'm talking about. But equally, if you don't have any Unity experience in you don't do games development or something like that, don't worry, because a lot of the stuff I'm going to talk about here is applicable elsewhere. It's not just Unity that does this. It's all kinds of other things like Blender, Houdini, and other types of game engines like Unreal and so forth. So we're going to have a look at that. And yeah, I'm very excited to get started. If you have any questions throughout this, please just drop them in the chat. I can see them here, and I'll highlight them and talk around them. But if you have any questions, you need me to clarify anything, please feel free to do that. So just a bit about myself before we actually begin. What I want to do is just talk about who I am. Some of you probably haven't seen me before. You're probably thinking, who's this guy? So my name is Benjamin Williams. I'm a research assistant PhD student here in the School of Computer Science. I'm also a senior games developer for a games development company that specializes in VR games. I've been making shaders now for years and years and years. I've been doing code and all that kind of stuff for yonks now. But I really like making shaders, love computer graphics. My research interests, I really love PCG, so procedural content generation in games, computer graphics, kind of the topic of this talk, virtual reality, anything to do with virtual reality, and my specific research interests for my PhD is sensory feedback congruency and motion simulation. So I really love all of these topics, but it's just to give you an idea of who I am and where I fit in the university, I guess. So the first question you might have is, why are we bothering talking about shaders? Well, shaders can take your game from something that is just 1 star to something that is 5 star. What separates games that have 1 star on I don't know, the App Store or whatever, to something that is 5 star visually, are really nice visual effects. And how can you create really nice, really interesting visual effects? Well, this is entirely what we use shaders for. There's other types of shaders out there, obviously, but the main reason we use shaders is to create very interesting visual effects in our games. The second reason is that shader artists are in demand, right? So making shaders is a specific skill set that not a lot of people have. And because of that, a lot of shader artists are in demand. If you want to get into this particular type of work, then you'll realize that there's not much shader artists out there. I think, as there's new tools coming out, like node-based editors and so forth, then slowly, people are becoming, people are learning how to make shaders more and more. But shader artists are definitely in demand. And if you're working in the games development sector and you want to kind of diversify your skill set outside of the games development sector, writing shaders is a really good way to do that. So shaders aren't just required in games development. They are required in all kinds of things. So for example, film and TV is probably the best example here. Whenever you have a big show, like a big name show, I don't know, something like Game of Thrones, all the visual effects you see in there use some kind of shader to create that. Any kind of computer graphics that we use, often we have to use shaders to actually render those through things like Houdini and so forth. I'm just going to hide this notice. There we go. So there are 3 reasons to learn shaders. It's also just a very interesting avenue of, if you want to build your skill set in games development, learning shaders is a really good way to do that. So about this talk today, there's going to be 4 real sections in this. So the first bit, we're going to talk all about shaders, and what they are. We're going to go through some examples of shaders that I've written mostly, but just to give you an idea of what we can do with them. I'm also going to do some primer in here as well. So if you need to touch up on your computer graphics and so forth, then we're just going to cover some very basic concepts in here. So you hopefully should be up to speed at that point. The second bit, I want to talk about shader graph essentials. And I keep mentioning this thing called shader graph, right? And that's what we're going to look at today. We're going to look at this system in Unity called shader graph. And it's the way to do shaders nowadays. All kind of game engines and tools and so forth use this node-based type of editor. So we're going to cover that. But before we actually get into using it, that's what we're going to do, is we're going to talk about what it is, what you can do with it, and so forth. And then finally, in this, well, I wouldn't say finally, in this third section here, we're actually going to do a live demo. So hopefully, fingers crossed, everything goes well. I'll minimize this presentation and we'll go into Unity and we'll create a shader. It's not going to be a AAA standard game shader or anything like that, but we're just going to have a look at how we can create these shaders. So hopefully, the live demo all goes good. We should be all right. And then finally, we'll close. I'll just summarize what we've talked about. And yeah, that's really the kind of overview of today. So before we get into anything, I want to talk about shading primer. So the first thing I want to mention is that 3D models are just made of triangles. If you've done any computer graphics, you'll realize that this is the case, right? 3D models, that's all they are really, is they're just made up of triangles. And there's a good reason for this actually, but I'm not going to get into it. It's because triangles are coplanar, and that's a really, really useful property when we want to render 3D models. But basically, yeah, 3D models are just made up of triangles. Graphics cards are built around this. When you throw a 3D model or you tell it to render a 3D model, graphics cards, that's all they love. They love triangles, they love matrices, they love these kind of things. So they're like, oh yes, I'll render that perfectly fine because it's made of triangles. So basically that's it. 3D models are just made up of triangles. But the question is, how do we actually define the triangles in the 3D model? Well, there are a few concepts that you need to know that I'm probably going to mention throughout this talk. But to demonstrate what these are, I've just got a cube here on the left. I've done my best to try and make it look 3D. So we just have a 3D cube here on the left. These points of the cube, so you see the points that define the cube. I haven't put in the last one here, which should be kind of around there. These are the vertices of the cube. So these points which make up the cube, these are called the vertices. And if I'm talking about just one of these, it's called a vertex. So the points that make up this 3D mesh, this 3D cube, are called vertices. So that's concept number one. The second is something we all know really, the faces. So the faces of a cube are just the sides of the cube, right? There's also you can't see it in this diagram, but there's another face kind of on this side of the object and this side, and there's a bottom face as well. But yeah, this is what the faces are. They're just the sides of the object. But yeah, it's pretty intuitive. This one is perhaps a little less intuitive. Normals. So the normal vector, that's what they're called. Sometimes normals. The normals of an object are the vectors which point outwards from a face. So for each face, well, it depends if you've got per vertex or per face normals. But let's just say face. For each face, there is a vector pointing outwards from that face that is perpendicular to the surface. So this tells you which way the face is facing. Facing is probably not the best word to use there. But you can see the orientation of the face. You know, this arrow here, up here, this is saying that this top face is pointing upwards. You know, we could have this face flipped around, right? And it could be facing inwards for some reason. But that's what normals do, is they tell you the orientation of faces. So if I say normal or normal vector, this is what I mean. I mean the orientation of a face. It's just perpendicular to the surface. And finally, and probably the most important one, is the edges, right? So we've talked about vertices, we've talked about faces, we've talked about normals. The last thing I want to talk about is edges. So what are edges? The edges are these lines, these orange lines. And you can see I've written in T1, T2, just replace T with triangle. So this is triangle 1, this is triangle 2, triangle 3, triangle 4, and so forth. So what the edges do is it tells you how these vertices, these points, are connected together, right? So for example, T1, it's saying that this vertex here is connected to this vertex here, and that's connected to this vertex, and it makes this nice triangle, right? Same for triangle 2, it's these two connected to this. And this is how we make up triangles in a 3D model, is we have a bunch of points, we call those vertices, and we say that how those vertices are connected is through these edges, right? We use edges to connect these vertices and make up triangles using those edges. So that's a very basic explanation of what's going on here. If you have a background in mathematics, you can kind of think of this as graph theory, right? Because these are vertices and these are edges, and we're just connecting them up in triangles to make a 3D model. So that's all this is really. Is just 3D models. That's all they are. They're just triangles. And to give you a better example, I just had a cube there, so you probably can't see what I mean by a model is just made up of triangles. So on the left, we have a Suzanne, the Blender monkey here, a 3D model. And we can see it on the left. That's perfectly fine. That's what we'd see in a game or something, or maybe it might be a bit smoother. But that's all this is. This is a 3D model on the left. And on the right, you can see these points, these dots. These are vertices, and the lines between them are edges. So we're connecting up these triangle by triangle. And if you look at this thing on the right, you can easily see that all it is just a bunch of triangles kind of stitched together, really. And that's what a 3D model is, really, is it's just triangle after triangle stitched together and in a certain orientation to create something like a 3D mesh. So that's all I'm talking about here, is 3D mesh like this is just triangles. That's all it is. So we've talked very briefly about 3D models, and I didn't go into much detail on that. So take it with a pinch of salt. But the one thing I want to talk about now is shaders. So shaders tell the graphics card how to render things. Basically, there's all different types of shaders out there, but that's all shaders do. Is they're just a little program on the graphics card which tells it how to render things. Something could be blue, something could be red, something could be transparent, something could be have some weird visual effect. A shader tells it how it appears on the screen, if that makes sense. So you have some shader here on the left. For example, here we have a GLSL shader. It has some kind of code in it. We compile that and we tell the graphics card, this is the shader we want to use to render the object. And this shader will render this model in red, for example. But this shader could equally render this thing as blue or something. That's what all the shader is. It's just a little program that we write in either code or we use a NodeBased Editor. There's all kinds of ways of creating these shaders, which is the topic of this talk. And then we tell the graphics card, this is the shader we want to use, and it will render something, a 3D model, in a particular way. And I'm kind of being vague here. You might think, oh, what do you mean by it tells it how to render things? We'll get more into that in a few slides. But that's all shaders are, is they're just little programs that tell the graphics card how to render things. Now, there's all different types of shaders out there. So I've got Vertex Shader and a Fragment Shader here, but there's others. There's geometry shaders, there's tessellation shaders, compute shaders. There's all different types of shaders out there. But the two we're going to look at today are the Vertex Shader, so a Vertex Shader, which is per vertex processing, and Fragment Shader, which is per pixel processing. It's a per pixel shader. And that's what we're going to look at today. We're going to look at these two classes of shader. These are the two ones you find most throughout shading and so forth. When you do 3D graphics and you want to create visual effects, usually you're using these two types of shaders. So the first one to look at is a vertex shader, all a Vertex Shader does is convert local space vertices of the model into world space. So what I mean by that is it takes the vertices of the model and actually puts them in the real world, right? That's all that happens. Is it takes local vertices and it converts it into where it should be in the world. So if you have an object maybe located, I don't know, somewhere off to the right, the Vertex Shader would be is the process of taking those vertices and moving them over to the right. So that's what happens here. Is we take stuff from object space, we move it into world space, and the Vertex Shader oftentimes is also responsible for taking that 3D scene and projecting it onto the 2D monitor that you're using. So it takes things from the world space into the screen space as well. And that's what this conversion process is really. If that's if that's a bit confusing, I've got an example here. We have an object that's just lying around here in this particular orientation. We take the MV, the model view matrix, and we multiply it by each vertex in this model, and then we finally have this object in world space. So that's what a Vertex Shader is often used for, is converting things from local space to world space. If that's still a bit confusing and you don't know, what's this space and what's that space? Oh, I don't know what that is. In terms of visual effects, we really use Vertex Shaders for controlling the shape of something, really, or where it is on the screen. So whenever you want to make a visual effect where the parts of the model are actually moving and the shape of the model is changing, that's when we use a Vertex Shader. And I'll get more into that, but that's what a Vertex Shader does. Now we can alter this conversion process for some really cool effects, and this is how we can make some really interesting visual effects, is by altering that conversion process. So here you can see it was just the model view matrix times by the vertex. If we change that process to the model view matrix times by the vertex plus the normal times by 0.2, 20%, then we can get this weird kind of inflated effect, right? So all that's happening here is each vertex is being moved along its normal, and that's all that's happening. So what this is saying is that the world position, O, is equal to the matrix to convert object to world, the model view, times by the object position plus the normal times by some scale. So all we're doing really is we're taking a vertex and we're moving that vertex along the normal by a certain value. And we can get this inflated effect, and we can use that for a bunch of different purposes. So if we did that inflation, but we added time into the equation and we scaled it by x, we can get this kind of effect where we have a kind of, I don't know how to best describe this, a kind of wibbly wobbly thing. I don't know. You get this kind of interesting effect, right? But this you could use this for a whole bunch of things. So, is this a heat wave effect? Is it maybe something rippling in the wind? Is it a hologram or something? Is this thing underwater? You could use this one effect for all those different kind of scenarios. So playing around with Vertex Shaders and modifying that process of converting between local and world space can lead to some really interesting effects. So that's what, in terms of making visual effects, we usually, like I said, use the Vertex Shader for modifying the shape of the object. If, for example, we do this inflation, but we do it over time and we just add it into a sine wave so it goes, inflates and then comes back and so forth, we can get this kind of effect, right? I mean, I know I'm shading it red here, but this could indicate that a bomb is just about to explode. So you can instantly see that just by adding in some tiny bit of code into that Vertex Shader, we can do this kind of stuff. So we can get some really interesting effects. If we have time, I might have a look and show you the code behind this later on. So we've looked at Vertex Shaders, which are all about controlling the shape of the object. The next one to talk about is Fragment Shader, a Fragment Shader. So this is run per pixel. So a Vertex Shader, you're changing the position of each vertex. In a Fragment Shader, it's run per pixel, so per pixel on the screen. And what I mean by that is, say you have this mesh that I made in Blender. If we have this mesh, if we took a cross section of this render, you can see that these these 3 by 3 pixels, these are the colors of them. So for each one of these pixels, what's happened is it's put the coordinates of that point into, well, it's took the XY coordinates of this pixel, it's passed them into the fragment shader, and the fragment shader has spit out this color, and it's set that pixel to that color. So what a fragment shader does is it determines the color of an object. Now, where a vertex shader, changes the shape of that object, the fragment shader can change the color of that object. And if you combine the two, you can do pretty much anything. You can do any kind of real visual effect. And I mean, there are exceptions and so forth, but just with these two shader types, you can create really interesting visual effects. But that's all a fragment shader does. You take the coordinates, it passes them into the fragment shader, and it comes out with a particular color. So if we set every pixel, if we made a fragment shader to set every pixel to black, like a black color like this, you can create something like a silhouette, right? So this is a very basic fragment shader where we set each pixel in the thing to black. You can get something like this, which is a silhouette shape. And it's not the best shader, but you could use that for something in your game. If you take each pixel and you compute the dot product between the normal N and L in this case is the light direction. So if you look at the light direction and you look at the normal and you do the dot product between them, and then you times all of that by red, or any color you want, blue, green, whatever, you can create diffuse lighting. So something like this. This is Lambertian reflectance. So simple diffuse lighting. All we're doing is we're just multiplying a color by the dot product between the normal and the light direction. So yeah, we can create some interesting effects. With just one line of code, we've got simple lighting. We can do other kind of weird effects as well. So if we take the fractional part of the position.x, so take the fractional part. If you're wondering what the fractional part is, it's just the point. It's just all the numbers after the decimal point. So it's the same as pos.x modulo 1. We take the fractional part of this position and we say if it's over some threshold value, then discard. So in this case, what we're doing is we're saying take the fractional position of this, the x position, and then just discard. So discard means don't render anything. Don't bother writing a pixel. So we can do some interesting stuff here. Maybe this is a loading effect, and you could turn this threshold from 0.0 to 1.0. So you could scale it and create some kind of loading effect. But all I'm trying to do here is show you that we can create all kinds of effects just by modifying our fragment shader. A vertex shader, we can control the shape of it, right? We can make it inflate, we can make it deflate, we can do all kinds of stuff with it. With a fragment shader, we can also do all kinds of stuff. We can do diffuse lighting, we can make a silhouette, we can do this kind of effect. You can do anything really. My favorite example of a fragment shader is this, right? If you combine this with a vertex shader, it's a really cool example. I love this example of a fragment shader. So this is just a shader, right? And as you can see, it's kind of putting snow onto the object. So why this is useful is that you can take a scene in a game, and you can make that turn into like a snowy environment just by changing parameters in a shader. So this is a really cool example where we're adding snow to a model procedurally, just by tweaking a slider. And you can imagine doing this for an entire scene. You can coat the whole world with snow just by changing a few numbers, and that's really interesting. So that's just snow without the hassle. So here we have a demonstration of this shader. It's just 20% snow. We have 40% snow, 60% snow, 80% snow, and as you can see, more snow gets added as that number gets higher. So it's a really interesting shader example. If you're wondering how that works, I'll briefly cover it here. All it's doing really is it's just comparing each normal. Remember, the normal is the perpendicular vector of a face or a vertex. So it's the arrow pointing outwards from the face, basically. We just compare that normal against the up direction. And if it's similar, in this case up in here in the top, this thing is quite similar to the up vector, this up arrow, which is always up, right? So we shade this in snow. If, however, it's not similar, then you get no snow. And that's it. That's the effect, really. So here's some code to do it. And as you can see, all these points up here, their normal vectors are very close to the up vector. So we shade this bit in snow, and we don't shade these. We don't shade this in snow. Yeah, that's basically the snow effect. I've got an example of that later on in this talk, and I'll talk more about it. But yeah. Now, that was the primer. I just want to go over shader graph essentials. So I talked a lot about what shader graph is. I've talked about node-based editors, but not really told you what they are. So I'll just talk about what shader graph is before we actually get into the demo itself. So Unity and shaders. So there's always been shaders in Unity. So if you don't know, Unity is a very popular game engine for creating games. And as part of that, it has shaders, right? You can create visual effects in Unity. Now, back in the days of creating shaders, you had to make them manually with CG and other kinds of programming languages like HLSL. So you had to sit there and type out the code, and I think a lot of people were put off by the language itself because it's quite verbose. But Unity is moving towards this thing called URP and HDRP, the scriptable render pipelines. So URP is the universal render pipeline, and HDRP is the high definition render pipeline. So HDRP is for really high fidelity photorealistic scenes. URP is basically for games, really. And don't worry too much about what these are. But as a result of this move, Unity moving towards these render pipelines, shader graph is slowly becoming the standard way to create shaders. So, my prediction, I don't have a crystal ball or anything, but in a few years' time, we'll see that most shaders, or nearly all shaders, will be created with shader graph. Now, shader graph, is a really interesting way of creating shaders. One of the best things about it is that anyone can pick this up. It's intuitive. It just makes sense. And I'll show you what I mean in the next few slides. The alternative way of creating shaders is, by actually writing code. So CG plus Shader Lab. There's other types of doing it like GLSL and transpiling to something like HLSL. There's all kinds of different ways of creating shaders. These are slowly becoming less feasible to use, especially in URP and HDRP. So as a result, shader graph now is like the standard way to create shaders in the latest builds of Unity. And as a result, there's quite a lot of attention in that area. So I've mentioned here, shader graph. What is this? Well, I'm finally going to answer this. It's a node-based shader editor. So instead of using text, right, instead of typing in text like you would with any programming language or any shading language, you actually just use nodes. So you have a bunch of nodes, you connect those nodes together, and it's almost like a visual graph. You can create shaders using this way. This is slowly becoming the future of creating Unity shaders, mainly because it's quite easy to do, and you can very quickly knock up a shader that does something. A lot of visual effects that we create in Unity, or for any game really, we're not looking at really high definition shaders with lots of inputs and so forth. We just want to make a quick shader that does something, like the bomb example. You could knock that up in, I'm guessing, probably about 20 minutes time. So it allows you to quickly and easily create shaders, and that's a very, very useful tool. And yeah, I've just mentioned that. I just answered this point here. Very quick for creating visual effects without the boilerplate. Yeah, that's one of the reasons that people are starting to use shader graph as well. So just to compare the two, so the traditional way of writing shaders is text-based. You have GLSL, HLSL, CG. There's all different kinds out there. In these, you'd write code like you normally would, right? You would write out actual code and then compile it. I might show you an example when we get into the demo. So this is very good for creating photorealistic effects. When you have lots of inputs and you've got to do a lot of calculations nested one within the other, you can create them quite easily using some kind of code, because it's a lot more easy to visualize rather than this huge graph of things. The other way, the new kid on the block, is node-based. So things like Shader Graph, Shader Forge, I think there's Shader Frog. What's that other one? I think it's called Shader Toy. I don't think Shader Toy is node-based, actually. Ignore me. But basically, yeah, node-based shader editors. There's all different kinds out there. And one of the leading ones is Shader Graph. So this is very good for creating visual effects with barely any experience in shader development because it's quite intuitive and it allows you to create very quick, very easy ways, creating visual effects. So if you have Unity, the first thing you want to do before you create a shader graph is make sure that your project is either a URP or HDRP project. So if you just create, when you create a new Unity project and you just click 3D, you need to select URP. So it needs a scriptable render pipeline. So if you want to look into creating shader graphs after this, when you start up and you create a new Unity project, just make sure that you press URP or HDRP. I would recommend URP probably because if you're making a game. But yeah, just make sure your project is either one of these. There's quite a lot of guidance of how to do this online, so just have a look at that. Then what you want to do is just right-click in the project window, then go to Create, and go to Shader, and just click PBR Graph. So PBR is physically based rendering, so a PBR graph. And then basically when it will create a shader, and you can double-click that, and you'll be able to edit it. And I'll show this process when we get into the demo, but that's really how you create a shader graph. Now, what this is what you kind of expect to see in a shader graph in a node-based editor. Okay, we have a bunch of nodes here, and we have some connections running between these nodes, and this defines our shader. So it's a hell of a lot easier to read than just some code. And pretty much anyone, given the right instructions, could understand what this is doing. So each one of these things, these rectangles, well, I suppose they're not rectangles, they're kind of rounded rectangles. There you get what I mean. Each one of these is a node. So we have a color node, we have an opacity node, we have a multiply node, we have an output node, right? So all of these are nodes. So nodes can have many inputs and many outputs. So for example, this multiply node, as the name suggests, it just multiplies two things, two inputs, and produces one output. So two things go in and one thing goes out. So maybe this first input is 2, and maybe this first input is, I don't know, 4. So this will do 2 and 4, 2 times 4, and it will set this output to 8, which is 2 times 4. So that's what nodes do, right? But they can have many inputs and many outputs. These things here, where there's just, well, okay, so wherever you have a node with inputs and a node with an output as well, usually what these are doing is they're transforming that data. If you have a node with just an output, these are usually called inputs because it's just a color and it just sends that color out. And this opacity is just a number, a float, and it sends this number out. So these are properties, these are just inputs to the shaders. Here we have an operator, so it takes in 2 inputs and it shoves out a output. So that's all it's doing, is it's transforming this data for us. So we call the connections between these inputs and outputs, we call them edges, very similar to 3D modeling edges and so forth. But what we're doing is we're saying this opacity is going into this input here, right? And then finally, the master node is almost like the main function. If you've done programming before, it's what the final color will be. It's like the main function. You do all your calculations here, and then you put the final color into this main function, and it sets the color rate to that. So what this is saying, if we read this now we understand what this is it's saying multiply red by 100% and set the output color to this. So we look at the inputs of this multiply. The red color is going into this input, and the opacity is going into this input here. So it's going to multiply this red color by this opacity, and then it's going to send it off, and this is going to be the color. So red times 100% is, well, it's red, so we're going to get red. But what if we change this opacity to 0? So red times by 0, well, this is going to give us a black color. So you can see that just by changing those inputs, we can get different colors. And this is a very basic shader. We'll recreate this in the demo itself. But yeah, I just wanted to show you what shader graph is. It's just a node-based editor. So let's actually try this out. So I'll try start this this example here. Before I actually get into that, I'll show you a GLSL shader editor. So I wrote a shader editor in preparation for this talk. So here we have a shader editor. We can switch to the Vertex Shader. We can switch to the Fragment Shader. And you know, we have an object here on the right. We can manipulate this and look at the object and so forth. But what this fragment shader is saying is that, you know, GL frag color, which is the output color, equals the normal vector. But we can change this to, you know, 0, 0, 1, 0, 0. So 1 is red, 0 is green, 0 is blue. You know, if we change this to 101, we get that. So we can quite easily, you know, change the color using this thing. So here's some examples. I've got like a rainbow kind of color, and you can see that this is just code. And what I'm trying to say here is that this is what you'd usually use. You'd use a text-based way of creating shaders. You type in the code and it would run that shader for you. And you know, here's another one. Here's diffuse lighting. We've got the normals again. But that's all really what I wanted to show you, is that we can actually make shaders using text as well. So onwards to the demo. Hopefully, I'm hoping this works. If we open up this Unity project here, I'll just move this here. As you can see, there's a bit of a scene here. I've got the bomb that I took a picture of for the for the slides. I've got this thing which I didn't show, which is a kind of billowing cloud thingy. I've got that thing, which looks very odd. I won't get into that. And we got that snow thing. So you know, if I change the snow cutoff value, I can make it have less snow. I can make it have more snow. And this is all done through Shader Graph. So what I'll do to show you how to create things in Shader Graph is, firstly, I need to make a test model, right? I need to put something in the scene that we can look at and test our shader with. So I'm just going to move in this Suzanne monkey model, and maybe now rotate it a bit, put it there, for example. The next thing you want to do, if you want to create a shader graph and put it on an object like this, you need to create a material. So materials have shaders, right? So if I click on this one, for example, it says that the material is snow, and the shader is shader graph / snow. This one, the shader is just, well, it's just that, whatever that is, right? So we need to create a material for this object, and we need to put that material on that object. So what I'll do is I'll just make a new material. So you can just right click create, and material, which is here, you can create a new material. And we'll call this, I don't know, test material or something. Now we have a material. I'll just change the color so it's a bit obvious what's going on. I can't actually see that. There we go. So here we have a material, and if I drag it onto this object, we can see that it changes color. So this object now has this test material, is now being rendered with this test material, right? And we can change the shader of this test material to whatever we'd like. But what we need to do is create a shader, right? If you've done Unity before, this stuff's fairly obvious. You know, I'm just creating a material and whacking it onto an object. Let's make a shader. So I'm going to go into shaders. I'm just going to right click, and I go up to create here. Now there's a bunch of different options here, but the one that stands out is this shader option, right? So we go into shader, and we can create all kinds of shaders. We can create a standard surface shader, unlit shader, image effect shader, and all these different types of shaders. You know, remember me talking about there's all kinds of different types of shaders out there. Well, you can see here, right? Straight away from these, you want to create one of these. So I would recommend going with a PBR graph. Okay, so just click on PBR graph, and we'll call it something like test shader. Right, so now we've made a new shader. And you can see the extension down here. It says .shader graph. So you can see that this is a shader graph. That's how you create a shader with shader graph. You just click you right click, go to create shader, and you click on PBR graph. It's as easy as that. Now, before we go any further, what I want to do is set the shader of this material to be this one that we've just created. Because at the moment, the shader is just one that's built into Unity. But but we want to use the one that we've just created. So we go to shader graphs here. So what you do is you click on shader here. And by the way, if all of this is a bit confusing, there is guidance on how to do this online. So just look up how to create a shader graph and how to put it on an object. So you click on shader graphs here, and you can see there's all different types of shaders that I've created. I've created the billow shader, the distance-based one, the pulsate shader, which is the bomb, the snow shader, and finally, the one that we've just created, as you can see here, is the test shader graph. So let's click on that. So now this object is being rendered with that shader that we just made. So, I mean, it's pretty uneventful. It's just, what's that, like a gray kind of color. So, is there something we can do which is quite interesting with this? Well, yes, let's edit the shader graph. So how do you edit the shader we've just created? Well, it's fairly easy. You just double click it. So I'll double click this, and you can see this window pops up. And what I'll do is I'll just make this a bit bigger so you can see. And this is shader graph. This is how you edit your shaders. And it's very similar. I mean, it's a bit more complex to what I showed you in the slides, but it's the same principle. All of these things are inputs. This is the master node. This is like the main function I was talking about. We can set the color, which is confusingly called the albedo. We can set the emissive color. We can set the metallic factor and so forth. But this is what shader graph is. You can move these around by clicking and dragging. I can move it around like this. So I can move this however I want. The other way is you can actually move around the scene itself. So I'm not actually moving this here. I'm moving my way around this this blackboard here. You can right click and you can click on create node. So you can create nodes like this. So if if here at the moment, this shader is just rendering this color, right? That's it. So can we create another node? Well, yes. If we just right click on this blank bit here, we can click create node. And there's all different types of nodes you can use here. There's blend, there's dither, there's all kinds of different nodes we can use. Now what I'm going to do, and this is another interesting feature it has, is you can type in one if you're looking for. I'm going to put a color. So this is just a color. That's all it is. It is just a red color, right? And I'll set the alpha up. So this is just a red color, right? And I can move around the scene like this with my middle mouse button. So I'm clicking down and holding my middle mouse button, moving around. I can left click and move this around this way. Now, how do I connect this color to the albedo? Because at the moment, it's just gray, right? Well, what you do is you click on the output of this and you drag and hold and just connect it to this albedo, just like that. And I can connect this to anything. I can connect it to this thing as well, But if you want to delete a connection, you can see it highlights nicely. You can click this line here and it highlights as blue, and you just press delete. And that's it. So if I wanted to get rid of this connection, I just click on it and press delete. It's as easy as that. So now we have a red color and it's going into our albedo, right? And as you can see, the preview down here gives you a good idea of what that looks like. So that's a really useful feature. I think you can make this bigger as well. Yeah, you can. No. Well, you can't make it bigger. I'm just being... oh, there we go. So you can make this preview bigger as well. So that's all this is doing. This is a very basic shader, but it's just saying it's taking a color and it's putting that color as the albedo. So let's see this in the scene. So what I'm going to do is I'm just going to unmaximize this. If I go to the scene, you'll notice this is just gray, but we've set this to red. It should be red, right? Well, no. What you're going to do, and this always gets me, is you've got to click Save Asset up here in the top left. So this will actually save the shader for us. So at the moment, it's just gray. If I press Save Asset and I go back to the scene, now it's red, right? So just make sure when you're creating your shader, always click Save Asset when you've done your edits and so forth. So next thing I want to do is just recreate that thing we had in our slides, right? Which was just a color, and we were timesing that color by a particular value, and then setting that color to the albedo, right? So here we already have a color. So I'm just going to get rid of this connection. I'm going to move this over here, and just move this over here as well so we can see a bit better. I'm going to create another node. We'll call this, well, it's going to be a multiply node. So as you can see, a multiply node takes two inputs, A and B, and it produces one output, right? And that's all a multiply thing does. And it's very similar to what we saw in the slides. So I've got a color, and I want to multiply this color by a value, right? So how do I do that? Well, if you go to create node and you type in float, you'll realize there's nothing there. Well, we've got an integer. There is, if you want to float, it's called a vector1, right? Which might be a bit confusing because you might, you know, the mathematical people in the chat might be like, God, why is it called a vector? It's only got one value. It's a scalar. I know, it annoys me too. But yeah, a vector1 is just one number, right? We can change that number. We can set this to 50. We can set it to 0.5, right? And that's what we're going to do. And we can, you know, we can set this color to A, so we can connect A to the color, and we can connect this vector1 to B. So we're timesing this color by this value. You can see this is going into B, this is going into A. Yeah, we've got a question in the chat. I'll highlight it here. Hi Ben, what is the best shader? If you mean what is the best shader in terms of best shader I've come across, I quite like the snow shader. I think that's my favorite example of a shader. If you mean what is the best type of shader to use, so Fragment Shader, Vertex Shader, Tessellation Shader, Surface Shader, all these kinds of shaders, I don't know. That's a good question. I would say PBR shaders like this, PBR graphs, are probably the best way to go to create most visual effects. There are all different types of shaders out there. I've seen some amazing one. Oh, what is the coolest you've seen? Well, I think, oof, that's a good question. I think I've seen a shader which takes the entire scene and renders it as a pencil drawing, which is, I found that amazing. I've seen some really cool water shaders, so making realistic water, that's also a very cool thing. Tomb shader, so creating cartoon effects, that's also a very interesting thing. If you want to have a look at, if you guys want to look at really cool examples of shaders, Shader Toy is a really good website that has a bunch of different shaders out there that you can use. Some people have created their own game engines within a shader, which just blows my mind. You know, they're rendering entire scenes in a shader, which just, I don't know, it just blows my mind. But I think, yeah, the best stylistically, one of my favorites is that snow shader. I think it's a really cool example because you can create a procedural snow effect just by, you know, using two calculations. It's an incredibly cool thing. I think they're probably my runners up. I think best stylistically, I think the pencil shader one is pretty cool. Yeah. So yeah. Anyway, to get back to this, so we have a color, we have a red color, and we're multiplying it by a value, so 0.5. So as you can see, if I set this to 0, I get black. 0.1, that's 10%. I get a kind of dark red color. If I set this to 0.9, it's very close. You know, I can scale this up, and if I do scale this up, you can see I can control how red it is, right? And it's not the best example of a shader, but that's all that's happening here. Is I'm multiplying this color by this value, and then this output I can set to the albedo. So now I can control the color of this object just by changing this number. And this is just a very basic example, but you can imagine using many different kinds of things like divide, multiply, all this kind of stuff. You could create some really interesting visual effects using this. So I'm going to save asset, right? And I'll go back to the scene. And it's red, right? But if I go down here, you'll see that I can't, here I could control this number, right? But now I can't control it outside of shader graph. So how do I do that? How do I make something that I can control that value outside of shader graph? Well, what I like to do, okay, and I'll maximize this so you can see. I haven't talked much about this thing here on the left. Now this is the inputs to the shader. Shaders can take inputs. They're called uniforms sometimes. But how do we create these inputs? Well, if I right click on this vector 1, there's a bunch of options, but one of them is convert to property. If I click on convert to property, you can see now it's changed appearance. This is now a property of the shader, right? And I can call this whatever I like. I'll call it maybe opacity or something. To edit the name, by the way, you just double click and you can change the name. So now I have one property, one input. So if I unmaximize this and I go back to the scene, you should be able to see. Oh, I think I've done that wrong. I think that might be my bad. Yeah. Oh, it's exposed. Yeah. Save asset. Go back. Yeah, you can now see that we have a number called opacity that we can change outside the shader and control the effect here. So, you can imagine all you have to do is, change this opacity to time, sin of time, and you've got something that flashes red like this. So, there's all different kinds of stuff you can do with these shaders. This is just touching the surface, really. This is scraping the surface, scratching the surface. I don't know what the phrase is, but this is the idea. Is this is just one way of doing it, right? This is just a very basic shader, but hopefully I've covered the basics of shader graph here. What I wanted to get across is that this isn't a talk on making shaders. It's more about how to create shaders in shader graph. So here, for example, we've just got a node. We're connecting this to that, and we're connecting this to that. That's a very, very basic example. I can, however, show you. An example of a shader. So, for example, we know the snow shader. Remember me saying that all we're doing is we're comparing that up vector to the surface normal. So if I double click that to edit this one, you can see that this is a much bigger graph, right? We've got, instead of just one thing connecting to others, we've got, for example, here we've got vector 3, 0, 1, 0, which is the up vector. And we're comparing the normal with, well, we're dot producting these, and then we're putting it into a step function, and then we're doing all kinds of stuff. We're lerping, and then we're setting this, and then we're piping all of these into the master node. So don't worry if this doesn't make any sense. This is just to give you an example of what you can do with these kind of graphs. It doesn't just have to be a simple graph with two things connecting to whatever. You can create all kinds. This is a fairly big graph, but you can do all kinds of different effects. There's, for example, I've got one here, the pulsate shader. So as you can see, the preview here, it's setting this to, it's changing the size of it. It's changing the color. So all it's doing is I've made a subgraph here. And maybe that's one thing I'll talk about, actually. I'm just trying to show you here that, there's all kinds of different shaders you can create. The world is your oyster, I guess. But yeah, let's go back to that shader that we created, this test shader. One thing I want to mention as well is if your shader graph gets quite big, you can, I think, I'm not sure, group selection, is that it? Yeah. So what you can do is you can click and drag to create a box. You can select all of these, and you can move them around as a group and so forth. You can right click on them once after you've selected these, and go to group selection. So now this is a group, and you can call this bit maybe red color or something. So now you can move all of this around as one. So you can actually make these a bit tidier. The ones I showed you, I don't tidy them up. But you can if it makes more sense to you to do that kind of stuff. But hopefully, that's covered the basics of shader graph, just to show you how to create nodes and connect them up. And I wasn't going to go into much detail on the stuff, but hopefully that's enough. I would recommend having a look at some Unity resources out there. It's really interesting. I think just have a look at the stuff out there, really. I've just scratched the surface on this stuff. So that's the end of the demo. A few tips before we end. We can do so many interesting stuff with shaders. Like I said, I've just scratched the surface here. I've just made a shader that can be red or black, and you can control it with a number. There are tons of resources out there, tons of resources out there for learning about shaders. The Unity documentation is a good place to start. The best thing I can advise if you want to create some really interesting visual effects is to think outside of the box, right? I mean, I was just showing you a number and I was multiplying that color by that number, but you can do all kinds. You can do whatever you like. You can put all kinds of different inputs into shaders. Just think outside the box and think how you can create stuff and how you can use it for VFX. So I've got an example here. What if instead of that input that we had was a number, we can control it with a number. What if we pass an object position into a shader? Well, we can do some interesting effects. Like the closer this object gets to the object that you're rendering, you can do this kind of stuff. You can set it to white or black, depending on this. And this is the basis of an effect I made a few years ago, where we're coating a enemy here, for example, with ice. It's the same deal. I've got an object position here, and we're just coating it with ice using this distance-based effect. So that what I'm trying to say here is that don't be limited by just standard inputs like floats and so forth. Really try think outside the box and what you can pipe into your shaders and do with them. If you need inspiration, there are some good links here. So Real-Time VFX is a very, very good site. If you're looking for inspiration, this is the place to go. They've got some really, it's basically real people who work in the VFX industry, and they talk about the shaders they've created. And there's some really interesting ways they've done it. So for example, the snow shader, I got that off this site. Some guy made it and I was like, oh my God, that's amazing. So have a look at there if you're looking for inspiration. If you want to have a look at some of those shaders on your own, the ones that I've talked about today, like the bomb effect, the snow thing and so forth, just go to this link here, Funky Unity Shaders. It's just on my GitHub. If you just go there, you'll be able to download the Unity project and have a look around yourself. A good resource for learning shaders in Unity, if you're looking at the text-based way, this is a really good channel on YouTube. It's called Making Stuff Look Good in Unity. One of the best I've seen. And the Unity Shader Graph series, so the documentation on Unity. So Unity created a video series on how to learn shader graph. So if you type in Unity Shader Graph series, it's a really, really good series of videos that will teach you how to, write things in shader graph. Probably a lot better than I can. But if you're interested and you want to know more, like if you've gone, oh, okay, that's quite interesting, I might try it, but I want to learn more about shader graph, have a look at that. Have a look at Unity's official shader graph series. It's a really, really interesting series. On that note, thanks for listening, everyone. I hope it all made sense. I hope it was interesting. I love talking about shaders. I could talk about this for hours, but in the interest of time, that's everything. I hope everything made sense, and hopefully I've inspired you to go out and try some shader graph. Again, have a look at those resources. But yeah, thanks for listening, and that's it. Thank you.